Hello and welcome to my channel. So today let's have a look at the question 2 of biweekly contest 70. Um, so it happened Saturday morning Pacific time. So this is how I did in the contest. So I actually spent quite some time on Q2. And then I also spent like a lot of time on Q3. So in the end, I don't have time to look at the Q4. So I'm going to firstly discuss Q2 in this video. So the Q2 is a 2145. Count the hidden sequence. So you are given a zero-indexed array of integers differences, which describe the difference between each pair of consecutive integers of a hidden sequence of length n plus 1. So more formally called the hidden sequence hidden when we have that differences I is hidden I plus 1 minus hidden I. So you are further given two integers lower and upper that describe the inclusive range of values lower upper that the hidden sequence can contain. So for example, given differences 1 minus 3, 4, lower is 1, upper is 6. The hidden sequence is a sequence of length n, whose elements are in length of 4, whose elements are in between 1 and 6, inclusive. So 3, 4, 1, 5, and 4, 5, 2, 6 are possible hidden sequences. 5, 6, 3, 7 is not possible since it contains an element greater than 6. 1, 2, 3, 4 is not possible since the differences are not correct. Return the number of possible hidden sequences. If there are no possible sequences, return 0. So the first example is the one we just saw, and so the possible hidden sequences are two of them. So the answer should be 2, and the second is has 4 of them, and third one, because of the difference between lower and upper actually is smaller than the max difference between the elements. So actually there is 0 possibility of a hidden sequence. So it returns 0. So let's make maybe a drawing to show what is the question is how we solve this question. So for the example 1, differences is 1 and minus 3, then plus 4. So it's about this. So firstly is 1 minus 3 and then plus 4. So we have actually 4 elements in the hidden sequences. So what we need to get actually is the minimum of the hidden sequence and the maximum hidden sequence. We're actually mainly interested in the difference. So we can call it D. And so we can actually see that in the lower upper, how many can we fit? How many such hidden sequences can we fit to the lower upper? So if a low is exactly minimum and high is exactly minimum, we actually can only fit one of this type of sequence. But if high in this equation, low is 1 and high is 6. So the difference between low and high is 5. So it's actually 1 more than the D. So we actually have two possibilities. So then actually we can derive this function equation. So the max minus low and upper minus lower So actually in the end we are just interested in this one is the answer we are interested in. So we can call it answer, but the answer might be much smaller than 0. So if the answer is smaller than 0, then we actually return the 0. So which means it's impossible. Upper minus lower actually is smaller than mx minus mi. So there is a problem of this question. I didn't think of in the beginning, but actually during the contest I got a wrong A, because then I saw the wrong A is like a hidden test case, so you cannot see. It just took me some time to figure it out. The reason is actually the difference is between negative 10 to the power 5 to the positive 10 to the power 5, and the n is 10 to the power 5. So if you add all the differences together, you might have 10 to the power 5 times 10 to the power 5 might be 10 to the power 10. So this is actually higher, higher than the integer range. So that's why you need to use a long format, long type to store that value. So that actually caused me like 2 wrong A's in the contest. So yeah, let's actually start. So firstly, we need to define. We can define as s is long, and we define the assign firstly 0 to this variable. Then we can have mean. We can have s defined as s, and the max is also s. So then we iterate through the differences. So we can add add the difference to the s. So actually the s, the value of initial value of s, it can be 0 or any like a small integer, because we are only interested in the end, we are only getting the difference mx minus mi. So here we need to update mi and also update the mx. Yeah, and yeah, here we, because we are yeah, we actually can firstly use a long type and then convert it to integer when we get the answer. So that we reduce the possibility that the intermediate sum is might be like too large or too small. So in the end, we just compare it to 0. If it's smaller than 0, we will return 0. So let's check the, and also this will be a linear time complexity. Also is ON. Okay, so I have all the 3 test cases pass. So let's submit. Yeah. So it had no problem. Yeah. So this is the Q2 of the biweekly contest. So if you have any question or suggestion, please comment. Thank you for watching. See you next time.